Let's talk Daikin D3 network. Now, this is the communication network that has been designed for VRV equipment. Why does that matter that we actually understand the communication circuit on VRV systems? Well, because sometimes we get U4 error codes, sometimes we get random communication faults, and it's important to understand the hierarchy of where these voltages are being generated and where they're going to, right? Where they start and where they end. You see, on an outdoor unit, just one-to-one, it generates 16.5 volts DC from this board, which is the carrier wave. On that carrier wave, it is sending plus or minus 5 volts DC packets to the indoor units, and back and forth they talk. That's how communication systems work. Well, when we add a heat recovery system, it's now this talking to a branch selector box or a BS box, and then that box turning around, taking those information packets that it got, and then sending them to the indoor units. And so there's that break in communication between the outdoor unit and the BS box, and the BS box to the indoor unit. Why is that important to understand? Because they're separate communication circuits, you can't just land your service checker wherever you want to and pull in all the information points. It's just not going to work that way. So when we're looking at heat recovery systems, it's important to connect either at the outdoor unit or in the F1, F2 in circuit between the outdoor unit and the BS box. Otherwise, you're not going to pull all that information in. Now, the other thing to notate here on this DC communication system, when we add a centralized controller, an ITC, or even an ITM, right? What happens? Well, this starts generating the 16.5 volts DC signal that then goes to the F1, F2 out on all the outdoor units, right? So this now becomes your main generation of your communication circuit, right? And so it's sending the 16.5 volts DC to the outdoor unit. The outdoor unit says, hey, there's a centralized controller here. I don't need to generate this anymore. And so it stops. And now all the outdoor units go into restart standby. They recognize that there's a centralized controller and they all stop generating the 16.5 volts DC. Why is that important to notate that these lose that power and the ITM is generating it? Well, because if you put the ITM 3,000 feet away from your outdoor units, you're going to have communication problems because now it's carrying the load of the entire network in the system. There's actually communication relays down here on the board that are designed to open that circuit and connect the ITM directly to all the indoor units or BS boxes on the circuit. That's why it's important sometimes when we're troubleshooting U4 error codes or communication issues on VRV equipment to isolate systems. That means remove the F1, F2 out wires when you're troubleshooting U4s on a system to rule out that it's not another system somewhere else in the communication network or your centralized controller that's causing the network to crash. Isolate the COM wires and troubleshoot the F1, F2 in wires to the indoor units or the BS boxes. And remember that just because there's 25 outdoor units on the building, you can't connect your one service checker to the system and see all of those inside. So see you guys on the next tech tip.